we have a differential equation in terms of x and t. And in order to solve the differential equation, we see that the dependent variable x and the independent variable is t. So in order to solve this, we must divide throughout by x squared and 1 plus 2x, so that we have 1 over x squared, 1 plus 2x, dx dt equals 1. Integrating with respect to t, we have the integral of 1 over x squared. We can just write this as 2x plus 1. We integrate this with respect to x on the left. On the right, we just integrate 1 with respect to t. In order to integrate this expression on the left, we have to decompose using partial fraction. So 1 over x squared, 2x plus 1. This can be written as a over x plus b over x squared. Yeah, this is a repeated linear factor. Just be careful a bit. And c over 2x plus 1. And we can write this as ax, 2x plus 1, plus b, 2x plus 1, plus cx squared, all over x squared, 2x plus 1. Equating the numerator, we see that ax, 2x plus 1, plus b, 2x plus 1, plus cx squared, this is 1. We need to find the values of a, b, and c. To find the values of a, b, and c, we can use a mixture of substitution and equating coefficients. If we let x to be 0, this first term is 0, the last term is 0. When x is replaced with 0, we just have b, and b is 1. If we set 2x plus 1 to 0, then x is negative 1 over 2. The first term is 0, the second term is 0. So negative 1 over 2 squared is 1 over 4c. This is 1, and c is 4. To find the value of a, we cannot substitute anymore. But what we could do is we can equate the coefficients of x squared. So equating the coefficients of x squared, you have ax times 2x. That is 2ax squared. So we have 2a. There is no x squared term for this second term. And for the third term, the coefficient of x squared is just c. On the right side, there is no x squared term. So the coefficient of x squared must be 0. And we see that a is negative c over 2. And since c is 4, then a is negative 4 over 2, which is negative 2. And the integrand x squared to x plus 1, we have a here, which is negative 2 over x, plus bx squared, b is 1, plus 1 over x squared, c is 4, and then we have 4 over 2x plus 1. Then from this part, we just integrate the right side with respect to x. We integrate negative 2 over x plus 1 over x squared plus 4 over 2x plus 1 with respect to x. Upon integration, this will give us negative 2 log x. That is negative 1 over x. And this part here is 4. But let's just do it this way. So in order to integrate 4 over 2x plus 1 with respect to x, we have 4, and then we have 1 over 2 log of 2x plus 1. Then in this case, what we have is, that is less, 2x plus 1 And then in this case, this will give us 2 log of 2x plus 1. So from here, this part is just 2 log of 2x plus 1. And on the right, we have t plus a constant of integration. We need to find a constant of integration using these two values. So we sub in x equals 1 and t equals 0. Upon substitution, you have negative 2 log 1 minus 1 plus 2 log 3. That is c. That will give us the constant of integration. 2 log 1 is just 0. So we have 2 log 3 minus 1. We need to express t in terms of x. So we write this t plus c on the left so that t plus 2 log 3 minus 1 equals negative 2 log x minus 1 over x plus 2 log 2x plus 1. And we can actually now move this 2 log 3 minus 1 over to the right, and we can rearrange this. We rewrite this as 2 log 2x plus 1 minus 2 log x. And then we have minus 2 log 3 minus 1 over x plus 1. The three log terms here can be grouped together. The coefficients is 2, and then we can use the quotient law so that we have 2x plus 1, and we have 3x in the denominator, minus 1 over x plus 1. This will give us the required solution.